friends, students, and enthusiasts. Welcome to my channel, that is Siddhartha Technologies. In this channel, I will teach you, or rather, I will be telling related to electronic subject, especially the skill subjects. Skill, that is hands-on skill. Okay, so today will be discussing, or rather, we'll be making one small IoT based sensor. The name of the sensor is traffic density sensor. Okay, so how to make it's a project also, because when you learn electronics, you should learn the overall things which are related to electronics, and that a sensor is very important part. Name this project or this thing as AI-based IoT traffic density sensor using ESP-32 live calibration and production. Okay, so either you can tell sensor, or you can give this name to the project. Of course, okay, we'll go to the abstract part. So AI-based IoT traffic density sensor. So why? Because the sensor will have a small circuit. So I have used a small ESP32 board over here. This project not only measures traffic density in real time, but also predicts future traffic congestion. That is, you will have traffic congestion on different roads, and especially on the signal area, signal lights. So for that purpose, this is very important project. So this is using an AI logic, please remember. So the system is widely used in smart cities, intelligent traffic signals, and urban planning. Traditionally, traffic systems rely on fixed timers and manual observation, what you see in your cities right now. Fixed timing and manual controls. But modern cities require real-time data and predictive intelligence. Our solution uses ultrasonic sensor, that is this particular device, or we call it as a sensor. It is based on IoT and AI algorithms to predict traffic before congestion occurs. So that is the main purpose of making this sensor project. Okay, so hardware components, what we have used in the hardware part, that is hardware components. So we have used hardware component like ESP32-S3 or C3 mini, super mini, and ultrasonic sensor and a Wi-Fi connectivity. Please remember, Wi-Fi connectivity is also there. Why? Because if the policeman is standing near to the traffic area signal, so he can just sitting on one place, he can watch the traffic congestion and other densities, what we will be discussing now. So sensor detects vehicle by measuring distance, while the ESP32 processes and upload data to the live dashboard. So we have used ultrasonic sensor, and of course it is working on a battery. So components are very, very less. The pin connections are very simple. VCC 5 volts, ground to ground. It is trigger pin, that is ultrasonic trigger pin is given to connected to pin number 5. Eco pin is connected to pin number 6. Please remember, eco pin is given. It is a better idea to give it via voltage divider. So I have given it here, that is eco to the ESP32, you have to connect 2 kilo ohms resistor, and from the same area, that is ESP32 pin number 6 to ground, you have to connect 1 kilo ohm resistor. So that I have shown it here. Okay, right. So now let's go a little detail about the prediction part, that is the AI part. Okay. So first of all, you should understand what is traffic density. You can change this value in your codes, which I will be sharing with you. So if it is less than 30 centimeters, this is only prototype, please remember. So distance detected less than 30 centimeter, it means vehicle is present. Okay. If the distance is 30 to 70 centimeter, partial congestion, that is partial, not very big and we're not very this thing. If it is more than 70 centimeter, it is free road. That means the gap is more. Okay. Okay. So that is the calibration, or rather we call it density logic, we call it as. So live calibration mode, what is that actually? Calibration method is keep road empty, note distance. You have to first, when you calibrate it, so you don't put any vehicles on the on your table or on your wheels and just note it the distance. Keep single vehicle present, note the distance. Adjust threshold value. Then you have to adjust the threshold value. If distance is less than threshold value, threshold distance, that is, then you can change it. Okay. So likewise, you have to make little changes in your topic. So let's go and we will just discuss more about the practical part so that you will understand uh, what is there. So one more thing I would like to tell you is the air traffic prediction in that air traffic prediction is ESP-32 stores recent traffic data. So whatever the traffic data are there, suppose 1 minute, 2 minutes, 3 minutes, the previous data that will be stored and applies a moving average algorithm. That is, moving algorithm will be there since we have just taking the algorithm from here. So it will be, we're just taking the algorithm and based on traffic trends, it predicts whether congestion will be increase or decrease in next few minutes. So this is related to artificial intelligence. Okay, so one more thing I would like to tell you, that is, since we are using IoT, on mobile application or a computer, you can check what are the prediction or what are the things you are getting there. Okay, so actually dashboard, what you will get, the density percentage. Okay, then prediction status, so that the help traffic authorities optimize signal timing and reduce congestion. That is the main purpose. What is a real-time application? Adaptive traffic light, highway monitoring system, smart cities. Just now we have discussed about that. Okay, so let's go to our lab and I will just show you the small demo. Please remember my lab as it is. I will be trying to show. I don't have a very fancy lab, but I want that you should get a real time idea. So let's go to the lab. So, all right. So here you can see I'm showing you the circuit diagram as well as the display which is coming here, that is IoT traffic density. The distance is 11.68 and density is 99% and status it is showing high traffic. Okay. So how's the connection like? Before showing the connection, I will just reset this again and show you. Okay, now it has changed. You can see 17.80 and still the traffic density is 99. Why? Because the threshold value we have kept it as say about 70. Okay, so status high traffic. Okay, so we can use the threshold values. We can use this thing, that is, we can change the values. Okay, first of all, this is my board. Okay, this is compact board. This is an ultrasonic sensor. We can use two sensors also. Okay, two sensors on both the side and two resistor, as I have told you in the circuit diagram, that is a pull up and pull down resistor from pin number 5 and pin number 6. Okay, that is from eco side. Okay, so 5 volt. This is running on 5 volt. I have connected a 4.2 volt battery. Approximately 3.7 volt is coming. So I've given battery connection. You can use a smaller size of battery. So compact size in a sense, it will be very small in size. So that you have to keep it in mind. Okay. So this is the IoT which will be displayed the density. Either it can be through cloud or it can be through mobile app also. Okay. So that you have to keep it in mind. So very simple connection, not a big this thing. The board is very small. Even this ultrasonic sensor, we can take it a smaller size, the professional size, and we can build it in a smaller. That means the size of the battery on the top of this board and on the top of the sensor. So a small size sensor, we can make it a combination of with IoT. So this is the project, what I just wanted to share to you. If you have any questions, of course, I will be sharing the codes also and the details also, right? So as you can see, the nodes are very small. So first of all, you have to select from tools, you have to select the board. So board I have taken at C3, that is ESP development board. You can just directly go into this, and this is the C3 board on the top. Okay, that would have selected. Second thing, what you have to select? You have to select COM port. That is, it's showing COM port 19 to me. Okay, so I've selected COM port 19. Please remember one more thing. Sometimes you will not get the connected to this IP address in the bottom. At that time, what you have to do is you have to go to tools and you have to select USB CDC boot enabled. Sometime it will be disabled, maximum time it will be disabled. You have to enable it. Okay, so these few of the points you have to remember. Why? Because the antenna part of this is little bit slow, right? So it will be little bit slow. So that's why you have to be little careful about that part. Okay, so threshold part I just want to show you. These are the HTML part. Okay, so you have to, yeah, distance it is given 60, density is less than 30. As I have explained you in this, you can go for more or less according to your requirement. Okay, so how it is calculated, that echo and all duration 0.34, that is the reflected wave for your ultrasonic sensor. And trigger pin high low, it has been described over here. And a Wi-Fi connection or baud rate, it is 11.5200. And Wi-Fi connection, whatever the local connection you have, you can give it. And simple trigger pin is 5 and echo pin is 6. So this is a simple program which I'm going to share with you, and you can make it by yourself. It's very, very simple. So I hope you will be liking this project.